and welcome back. In the last video we streamlined our code by using locals and variables, and now in this video we're going to make our code even more leaner with the introduction of meta arguments. So we're back over on our client machine. Just a quick recap, we've created a resource group and 2 storage accounts. Obviously we've used 2 separate resource blocks to create that storage account. One for diag and one for guest. So that's not ideal because we're using basically the same code. There's only a few variants in there. So what we can actually do is we can use, if we just comment this one out for the moment, we can use this block here to create two storage accounts. And we can do that by the use of Terraform Meta Arguments. We've already seen some meta arguments in a previous video where we use the depends on. So that's a type of construct that Terraform provides us that we can apply to a resource block. So there's another couple that we can use, and we're going to see them in this video. So the first one is count. So we can actually say we want 2 of these. We do need to refactor this a little bit because obviously we don't want it to be referenced as diag anymore because it's a bit more general. So let's generalize that and call it SA. And we don't really want to give it the name diag on both of them because obviously one's for a guest account, and also the name needs to be unique for a storage account. So we can't just create 2 objects with the same name. So let's get rid of that for the minute. So how do we address this? Well, using the count, what will happen is Terraform will go through this twice, and the first object it creates, it was going to give it an index, and the second one it'll give it an index incremented by 1. So the first time it loops through, it's going to give it an index of 0, and the second time it goes through, it's going to give it an index of 1, and then if it was third, it will go through and give it an index of 2. We can actually use that value here. So if we specify another variable here and call it count.index, we can actually grab that value, place it there. So the first time it goes through, it's going to create this name with 0, and then the second time it goes through, it's going to create this name with a 1. So let's check that out. Let's do a Terraform plan. Okay, so that's finished, no errors. So let's scroll up and see if we can see what names it's given our storage accounts. There we go. So that's obviously the second one in the list, dev1, and there should be a dev0 if we can find it. I'm trying to go slow enough so we don't miss it. There we go, dev0. So that's all great. It's made us our unique storage accounts, but we want one to be appended with the word diag for our diagnostics, and we want one to be appended with the word guest for our guest account. So at the moment, Terraform has got no idea that we want to do that. So what we can actually do is we can actually add another variable. Let's call it storage accounts. And we can actually create a type, and we can set it to basically a list of strings. Let's type it right. And we can give it a value of, so we can set the default to say, so we need to create an array this time because we're going to create a number of objects in this, but it's going to iterate through. So let's give the first one diag, and the second one, I forgot what it was. That was guest, wasn't it? Guest. And then we can use this. So basically we've got this variable that contains 2 string objects. Now we can actually use this here. So instead of using count, we can use what's another meta argument for each. So we can say storage account. So for each, not for our storage accounts, it's very similar to count, so it's going to know that it needs to go through twice. So the first one and then the second one for diag, one for guest. But this time we can actually use that value in this environment variable, and we can say each, which is basically a reserved name for Terraform to reference the object that it's iterating through. So each dot value, and value being, if I can spell, and value actually being the value that we're passing in. So the first argument is going to be diag, and then the second one will be guest. So that should produce what we need. So let's have a look and see if it does. Let's clear the screen now. So we'll do another Terraform plan. Okay, all finished. Let's quickly find one of those. Make sure it's got what we need. There we go. And it's putting guest on the end of that one. So that must be the second one in the list. I won't scroll up to find the other one because it takes too long. So yeah, that's met what we need. However, there's still a slight issue. Later on, when we actually want to put stuff into this storage account, how do we identify it? So previously, when we had 2 resource blocks, we could have referenced it by using either guest if we want to go into guest, or previously it was diag up there, and we could actually reference diag. So actually, it's probably best if I explain by example. So let's create a new resource. Azure RM storage container. So for those that don't know, when you create a storage account, you can create objects in that storage account. In this case, I'm just going to create a storage container, which is basically a blob container. I think it's container, yeah. And just give it a name test for the moment because we're not going to keep it. So that's going to need a name, and let's just call it folder 1. And now it's going to need to know what storage account to put it into. So how do we tell it we want it to go into, say, the guest storage account? So obviously we now know it's in this reference, so we can use that. But we can't just do .name like we would previously have done, because, well, there's 2 objects in here. And we can't just go to guest or dev diags, because obviously that doesn't exist anymore. So obviously we can access it by index. So if we want it to go into guest, we can do 1, index 1. I think that should work. Or if we wanted to go into diag, do index 2, 0. Get my numbers right. And that should work. But the problem is, let's say it's we want it to go into the guest, which is the second object. So a 1. God, I'm going to get this right in a minute. So 0, 1. So it's going to reference that. Great. So it's going to put it in the correct storage group. But what if someone come along and added another storage group in the future? Say another. That's no longer index 1. That's index 1. See the problem? It's fine if guest is always going to be the second reference, but we can't guarantee that someone in the future is going to change our code and add an additional storage account, and and it's going to maintain that. So we basically lose our index potentially. So we need to future-proof this a bit better. So what we can actually do is, if we actually just go back to here, we can change this. Let's change it to something else. So let's do a map this time. Map of any type. And instead of having it like this, let's create a number of objects. So the first one, so when we create a map, we can actually specify an object and a number of key value pairs, and we can actually assign that object a key. So let's assign the first one diag as a key. And let's create a second one for guest. So this is going to be the key name, and in these squirrely brackets we can actually define additional value key and value pairs if we wish to. But for the moment we just need the key, so that's fine. So we can use the same loop, so it's still for each going through this value. This time it's going to go through diag and guest. But instead of having the value, we can actually put the key. So what that's still going to meet the same thing. So it's still going to be the word diag, because that's the key value name. But this time we can actually refer to that in here. So let's put it in the guest. So it's going to look for this reference, and it's going to look for the object with the key name of guest. What this allows us to do is we can change anything in here. We could add another thing up here, for example, another storage account to create, and it doesn't matter what order it's in, because it's going to look for the key value of guest. So let's just make sure that works. Let's clear that down. So Terraform plan. Okay, so we're all good on that front as well. So let's just check, make sure it's done what we want. We can find one of them again. Yep, so there you go. It's given that one guest, and there'll be one further up for diags. And we can actually create the container in the guest, and it really doesn't matter what order now that we provide this in, because it's not relying on the index number at all. So that's really good. What else using this method has allowed us to do, though, is another benefit. So let's say we want the diag to be, let's have a look. So we've got both of them at the moment. They're both being created as a standard account tier, and the replication type of both local redundant storage. Let's say, for argument's sake, that we wanted the guest account to be a different replication type. So at the moment, we can't really do that because we've got it hard coded. But now that we're using this map feature and we've created a key, and we can actually now add key value pairs. So let's grab that and place it in our model. If you remember, let's tidy that up a little bit. Terraform. So remember, we've got this Terraform format command that we can run that tidies up our code. So let's run that again. That's made it a bit prettier. So what we can do here, so we keep it as standard, but maybe we want, we want to keep the diag as it is, but the guest one we want to change. So what we can do is change that to zone redundant storage. And then down here in this, so what I've done, let's just sort of review. So obviously we've got this object, and it's got a key value of that. And in that key, we've got some other parameters, key and value pairs, that we can now define. And we've got that for both objects. So if we go back down to our thing here, so we should now be able to go each dot, each dot value, and we can refer to the account tier value. So that would be this one for diag and this one for guest as it iterates through the list. And we can also do the same, obviously, for the value we want to be different between the two storage accounts. In this case, the account replication type. Okay, so let's run that. So what this should be doing, it should be still creating two storage accounts, but this time one will have a value of local redundant storage for its replication type, and the other one will have zone redundant storage. Okay, so let's scroll up. It's going to be even harder to find the zone redundant storage in here. There we go. So account tier. Somewhere in here, it's going to show us. In fact, it's too hard to find. Let's actually just deploy it and have a look. Before we do that, though, let's tidy this up, because we are actually going to create a storage container. So rather than just call it test, let's call it guest. Because if you remember back to our diagram, we did actually have, we're going to create on the guest storage account, we're actually going to create, that's where we're going to store our scripts for the custom script extensions. So let's create a folder called scripts, and we're going to put it into the guest. So we can actually reuse that. So we don't need to delete that. Let's deploy what we've got. Let's do another plan. And then we'll deploy this and we'll check it out. Okay, so that's finally finished. Let's head over to the portal and take a look. So let's go to resource groups. So we've got our resource group. Let's create two storage accounts, both in West US. The guest one should be zone redundant storage. and it should have a container called scripts. Okay, it's got a container called SC tips, because obviously I must have spelled it wrong. So let's quickly fix that. Yeah, there we go. My poor typing strikes again. Let's call it scripts. And let's quickly create a new plan and update that. Okay, so let's create a new plan. Let's apply that new plan. Okay, so that's finished. As you can see, it's added a new resource, so our new container, and it's actually destroyed one because obviously we can't rename a container, so it has to delete the old one and put the new one in. So if we head over and do a refresh, let's see if it's updated yet. There we go, it's now fixed our problem. Okay, so we're all good there. So now we've got all this code. This file main.tf, we've put it all in there. It's going to get a bit unmanageable going forward because it's, you know, we're going to have loads of variables in there. We're going to have loads of additional resources we're going to add as we're going. So let's tidy this up a little bit. So we know we don't need that anymore because we've now got this resource block creating all our storage accounts we require. What we can actually do is we can split this out into separate files to make it a bit easier for us to manage going forward. So the first thing I'm going to do is I'm going to create a new file, and we'll call it providers.tf. And what we're going to do is we're going to take all the provider information out of this main.tf. So let's delete that and let's add it to providers.tf. We're going to do the same for variables. So let's create a variables.tf. And let's do the same. Let's take all the variables out of the main as well. Delete those out of there and stick them in variables. So that hasn't broken anything. So what Terraform's do, when you run the Terraform commands, it takes all any file with .tf extension into account and sort of like merges them on runtime. So it's really just to help us admins manage the code a bit better. So that's a lot neater, isn't it? So we're working this file to create all our resources. We're working this file to create our variables. And if we want to make changes to our providers, it's in this file. Just makes it a lot easier. Let's just make sure it still validates. So let's create a new plan just to make sure it still works. So no problems with that, all good. So our refactoring has worked. Right, so what we haven't covered yet is the Terraform state file. So at the moment we've got a state file in our project. So that got created the first time we did a Terraform apply. So it's created this state file. We shouldn't look at it, but it's basically a massive JSON file. Don't edit that. Don't do anything with that. Just leave that intact. Let Terraform take care of it. But the problem we've got is it's local to our machine at the moment. And now our project's going to grow a bit bigger. We're going to start adding more and more resources. We might want some colleagues to help us. And, you know, we don't want to get to a point where the hard disk fails on my client machine, for example, and we lose that TS file. So what we need to do is we need to make it a bit more available to other engineers that may be working on the same project, and also for resiliency and, you know, to keep the file safe. So what we're going to do in the next video is we're going to make that TF state file a bit more highly available, and we're going to use a concept called remote state. And what that involves is copying that file up to some kind of remote storage. Obviously, because we're doing Azure, we're going to put it into an Azure storage account. We're going to configure the back end so that the Terraform code knows to go and update this file, and that will allow us to collaborate on the same project with multiple engineers, and it also provides us a bit of a fail safe in case our hard drive fails. So thanks for watching this video, and then in the next one we'll cover the TF state migration. Thank you very much.